All right, so we're ready to look at the exponential growth worksheet. So this is, first we're looking at carbon-14 dating, right? So carbon-14 is an element that naturally builds up in, and this is a typo, right? No, it's not supposed to be pants, right? It should be plants. So this should be plants and animals during life, right? And then will decay exponentially after death at a rate of 11.4% per millennia, right? Millennia is 1,000 years, right? So number one says use the equation factor equals 1 plus or minus rate, determine the decay factor for carbon, right? So in other words, if you remember the equation that's in the book, so this was on page 6-8, right? Remember, you have this equation: P equals P naught times 1 plus R times T, right? Where this is my initial value, right? This part is what we're concerned about, the factor, right? This is my factor, 1 plus R. So if R can be negative or positive, right? If R is negative, that would be a decay factor, and if R is positive, it would be a growth factor, right? So here we're decaying, right? Decay. So R is negative. So my factor would be equal to 1 minus 11.4%, right? Or in other words, 1 minus 0.114, right? So if we do this, we take 1 minus 0.114, we get 0.886, right? So that's my factor, 0.886. So then now we're assuming we have 100 grams of carbon-14 to start, and we want to fill in this table, right? So in other words, after every millennia, we're going to take the previous amount and multiply by this factor, right? So to get this amount here in this table, you're going to take 100 times 0.886, right? So if I take 100 times 0.886, I get 88.6, right? So this would be 88.6. So then next along, I'm also going to multiply by 0.886. So times 0.886, hit enter, and we get 78 points. So we can round. We'll do 0.50. Right? So I'll round that to 2 decimal places. And then if I multiply again, I get roughly 69.55. Right? So I rounded those to two decimal places when as needed. So those are the values, right? So now we want to try to build my equation, right? So I need to put it in this, I can put it in this format, right? So I want to use C for amount of carbon remaining, right? So this would be C equals, and then my initial amount here would be 100, right? Because that went with 0, right? That's my initial. And then we would have times 0.886, right? My factor. And then raised to m, my variable m, right? That's the time going on, right? After every millennia. Right? So there's my equation. And just a note, right? When you see like P naught, this is initial, it could be population or whatnot, right? So we use that in math and physics a lot, right? So for example, in physics, you might see V naught, V sub 0. This means initial velocity, right? So it's a way for us to code that variable. So when you see a subscript of 0, that means initial, right? So that's my initial amount, right, of 100. Right? So now we're ready for number 4. So in order to look at number 4, you are going to need to use the equation that we haven't looked at yet using Euler's number. So this is on page 8 still, 6-8, so page 6-8, where we have these three equations, right? So now we want to use the one y equals a times e to the k x, right? Where it's important to know here that k is what we refer to as the continuous growth rate. Continuous growth or decay rate, right? So obviously if k is bigger than 0, it's a growth, and if it's less than 0, then it's a decay rate, right? So we're given, so remember in Excel when we do a, so this is in Excel. When we work in Excel and we get the equation for a exponential trend line I showed you in the last video, you're going to get your equation in this format, right? So these two are in the same format. So so what's asking you is, what is the continuous decay rate for carbon-14, right? So we could say we could say that the continuous decay rate for carbon-14 is 12.1%, right? So I took this number and turned it into a percentage, right? So I moved the decimal point 2 spots to the left. It would be here. And notice, since I say decay, I don't put a negative sign in front, right? That would be like a double negative. So if you say the word decay, you don't need a negative sign, right? Good. So then part F asks us to use the equation from Excel or your e to the x button on your calculator to compute the amount of carbon-14 left after 8,250 years, right? So we can certainly do that, right? My equation is y equals 100 e to the negative 0.121 x, right? So I need to find what x is. So if you notice up here, x is the number of millennia, right? The number of 1,000 years. So x here would be equal to 8,250 divided by 1,000, right? Or simply 8.25, right? So that's important to get the right x value. So if I plug the x value into here, then I can get y, right? So I'll show you how to do that in your calculator, right? So turn it on here. So you're going to want to look for a button that looks like this, right? Something to this effect. Right, you'll notice it's in blue above the LN button, right? And that's pretty typical for it to be in that location with the LN button. So you hit second, this LN button, to get that e to the x power. Whoops, and I forgot to type in the 100 first. So let me clear and do that. So 100 times, and then do second, and then the e to the x button. And then now we need to put in the exponent, right? So it's negative 0.121 times 8.25. Right, and if I hit enter, we'll get that amount. So it comes out to be approximately 36.85 grams, right? And we can also get that in Excel, right? So let me open up Excel real quick and I'll show you how to do that. I'll zoom in so you can see what I'm typing. All right, so we can just type in equals and then do 100 times, and then you'll type in exp function. So then now inside of here, you're putting in the power. So this would be negative 0.121 times 8.25, right? Close your parenthesis, hit enter, and you get the same value, right? So that's how you can do that in Excel also, using the exp function. All right, so that's all there is for this video. I'll see you guys later.